Okay, now that I have the right microphone. How's everybody doing? This is Functional Reactive Systems. If you're looking for the knitting class, that's, I think, Franklin 5, so you're in the wrong place. Yeah, okay, so I'm your host. This is a photo of me in case you don't know what I look like. You may know me from the internet, associated with such projects as some random PHP frameworks. I also worked on Angular UI Router for a long time. How many people have ever used UI Router? Just awesome, my people. Woo! All right. I also I work on my couch as an architect for a consulting firm called Ratify. We are actually hiring junior Angular developers, well, junior JavaScript developers who do Angular. So yeah, see me after class if you're into that sort of thing. You can reach me at this talk for purposes of ranting or collaboration, or if you have money you would like to give me for doing said architecting, you can find me there or on Twitter. All right, so just quick bit of housekeeping here. When I showed up today, I didn't actually know I was going to be speaking. So this talk was prepared somewhat in haste. As a result, I've decided to include an attendee license agreement, which goes like this. So you have permission to watch this talk, learn things, create with no restrictions, and create derivative works based on the things you learn from this talk. You can also learn future things and combine it with these things to create things, or entirely disregard it. But this talk is provided as is, with no warranty or fitness of any kind, for including but not limited to merchantability, fitness for any particular purpose, or non-infringement. So if my talk infringes on someone else's talk, sorry. Basically no refunds. So functional reactive systems, functional reactive programming, how many people have heard that phrase before? It's basically just a bunch of buzzword bingo. It's very, people describe these topics in very heady ways. But fundamentally, the terminology is really simple. So functional, first of all, there's no real completely accepted definition of functional programming. Basically, it involves composing your business logic from lower order functions to higher order functions and building up from there, keeping those functions separate from the data as opposed to object-oriented programming, which combines them. And it has ideas about purity and managing state, which we'll look at briefly. What about reactive? Basically, like, everybody's kind of seen sort of the new school React Redux sort of paradigm. And there's no real clear definition of what reactive means, again, other than it has to do primarily with time and treating time as a first-class thing that we think about in our software. Finally, systems. It's a really broad topic. Deals with back-end stuff that we really won't talk about today. So we're just focusing on the front end. So let's get into functional a little bit. Like I said, functional programming is about composing functions from smaller functions into more complex functions that do more complex things, and using that as the sort of and using functions as a unit of abstraction to describe your business logic as opposed to modeling things out as objects. Related to that is the principle of separating data from behavior, and we'll look at an example of that as well, where you have your functions instead of objects which have properties and methods all combined in one place. Functions are the behavior that's separate from the data, and then you have data that you operate on with those functions. And finally, functional purity. And this gets into a lot of very heady academic terms like stateless and referentially transparent. They all generally boil down to the same sorts of concepts. So we'll look at a few examples of what those are as well. So some functional libraries for doing functional programming. Functional programming has kind of been the hotness in JavaScript for a while now. Lots of libraries advertise themselves as being functional, such as underscore and Lodash. Those are big fat lies. underscore and Lodash are not functional libraries, even though they advertise themselves as such. And we'll look at why that is as well. A library that is a functional programming library for JavaScript is a library called Ramda. So all of the small number of examples that I have today will be in Ramda. So let's take a quick one. Suppose we have a list of people and we need to extract out all the names. So we want just an array of just the names for display purposes or whatever. So we can bust out our old friend, the for loop, iterate over them, pull out the names, push them into a new array, and be done. But now what happens if we need to do something else in that loop? We call another function. Maybe that function has some kind of transitive dependency on the result. Maybe it has a transitive dependency on the thing that we're iterating over and it gets modified. So there's all these opportunities for side effects to happen. Not only that, but we're creating this variable, this I counter specific for this loop. It doesn't need to live outside of this loop. It serves no purpose. But suppose somebody else accidentally uses it without redefining it, then we have other problems. So again, this is kind of a superficial example, but you can imagine, doing, even in a trivially simple code base, you would have many examples like this where opportunities for collisions in state to happen, or opportunities for state that you're working on one place to be modified in another. And more importantly, possibly most importantly, is that what you're doing gets lost in how you're doing it. The what gets lost in the how. So you can skim over that and say, okay, it's pretty obvious what this code is doing. But again, imagine this snippet in hundreds of lines of code. How quickly can you really skim that and determine what it does just by looking at it? But we know, this is 2016. We know what we're doing. We'll use the map function. So we'll map the array, make a shorthand function that converts the person to the person name, and we're done. So that's pretty simple, much more terse. Doesn't have any of the other problems that the stateful for loop had. But we can go further than this. So this reads even clearer. We can take this functional library called Ramda, which has a function called prop, and we can say, I want the name prop, and then I can map over that function with my people array. But we can even take it one step further than this. We can actually import another function called map, which does basically the same thing, except it switches how you call it. So here, we can actually completely encapsulate the behavior inside a higher order function called names. And now our behavior is fully generalized, and we can reapply it to anything that, any other data structure that has names. And so we call our names function with people, and we get our names list, and again, we can pass any other thing that has names to do that. So how does this work under the hood? Ramda has a function called curry, which if you ever heard of currying or partially applying or partial application or partial function, semantically those are all different things. Ultimately they all refer to the same basic idea. A curried function is one whose arguments can be, you can keep calling until it gets all of its arguments. So here's a simple re-implementation of the prop function, which is just a function that takes a name and then an object. But because it's curried, I can call it all kinds of different ways. So I can pass it the name, and it's going to return me another function that takes an object, and that's equivalent of calling it like however many times until it gets all of its arguments, and then it returns an actual value. Does that make sense? Yes, nodding, great. So two important things to note here. First is the fact that these things are curried. Second is the parameter order. So if you'll notice, the kind of Lodash underscore style would be to do object and then name. Or for map, which works the same way in Ramda, you give it the callback and then the array. Lodash and underscore are the reverse. So in Lodash or underscore, you give it the array first and then the callback, which isn't going to work if you're trying to describe your behavior and keep the values separate. So that is functional programming in a nutshell, at least the important bits of it. So now we'll take a look at the reactive part. Basically, this is implemented with what are called observables. So these go by many different names: the observer pattern, publish, subscribe, streams if you're familiar with streams in Node. But most libraries these days refer to the concept as observables. So you can find observable libraries that help you do stuff. So let's talk about what observables are in terms of another similar abstraction that we all know and love called promises. So you're probably familiar with promises. Promises and observables are both different kinds of abstractions, and they both help with managing discrete actions over time, also known as async. So how are observables different? So as different types of abstractions, each one has properties that allow us to reason about them and about their behavior. So we know that promises are asynchronous. It represents a possible future value. It represents either that future value or failure to deliver that value. And it represents exactly one value. You can't replay them, you can't, that's never gonna be more than that one thing. And they're immutable. So once the value resolves, that's it. You can replay, or you can resubscribe to that promise as many times as you want. It's always gonna return the exact same thing. And another really important property of promises is automatic flattening. So if you have a promise and you return another promise from that, the resolution of the inner promise is the resolution of the outer promise. So you don't have to think about, gee, how many promises deep did I go and how many times do I have to unwrap that? It just does it all for you. So that makes it really, really simple to think about doing asynchronous things that depend on one another without having to worry about the mechanism so much. So what about observables? Observables can be asynchronous or asynchronous. There's many different types. They represent 0 to infinity values. So you could have a stream that terminates or an observable stream that just goes on for infinity. Unlike promises, they do not do automatic flattening. So if you have an observable that returns another observable, you are kind of on your own to keep track of that and flatten it. However, most libraries do have operators that will flatten those for you. So we'll look at that. So what are promises good for? Promises are good for HTTP requests. We now have in-browser functionality in the form of fetch that bakes that right into standards. We all know promises are great for HTTP. What else? Not a whole lot. That's not strictly true, but generally speaking, promises are really only great for things where you're only doing one thing one time. What about observables? Observables are great for HTTP and events and WebSockets and iterators, and you can even use them for arrays. Basically, it's a very, very general tool. It's used to manage all kinds of different, it's used to model all kinds of different problems. So, what are these magical capabilities that observables have that promises don't, that allow it to be used for all these different use cases? So first of all, observables are cancelable. So have you ever had a thing where you're firing off a bunch of HTTP requests based on user input, and then the input changes, and the HTTP requests, you don't care about them anymore? Well, with promises, there's no way to cancel a promise. It's immutable. The request is fired, and that bandwidth and those resources, those are consumed. So you are out of luck. Observables can also be retried and replayed. So if you have a request that fails, or if you have a new subscriber that needs updated data, you can ask that observable to replay whatever it just did. And you can chain observables just like you can chain promises. So when you replay an observable, it will go all the way back up the chain to redo whatever it did. And you can control that with different operators. So what about observables versus promises in terms of, are there anything that promises can do that observables can't? Nope. So, observable libraries. There are a number of different ones. Bacon.js was kind of one of the earlier ones. Very small, simple library, gets the job done. Highland.js is sort of like the underscore or Lodash equivalent of doing observable async stuff. Cycle.js is not an observable library, but it's actually a framework, a simplified framework designed around observables that allows you to do all this stuff with really nice abstractions. RxJS is kind of the big granddaddy of them all. It's been around for a really long time. It recently underwent, the JavaScript version of Rx recently underwent a complete from the ground rewrite for version 5, so it's a lot cleaner, uses new JavaScript abstractions, and it's all brand new and shiny. And the other interesting thing about Rx is that it has implementations for just about every library, or every language rather, that you could think of. So if you learn it once for JavaScript, you can apply that mostly to just about any other language that you need to use. And finally, I wanted to mention Angular 2. Again, Angular 2 is a framework, not an observable library, but it is based on RxJS and has observables baked into the core. So similar to Cycle.js, it has a lot of nice abstractions that help with dealing with asynchronous stuff in a clean and succinct way. So let's take a look at some examples. So we can create observable streams from all kinds of different stuff, and the observable library has different helpers to create observables from arrays, from promises, from events, WebSockets, et cetera, et cetera. So we can create a stream of click events from a given element and give it an event name, and it'll create a stream. And then you can subscribe to that stream, and every time you click, you get some output in the console. So pretty straightforward. What if we want to do something a little bit more advanced? Let's say we want to actually map those. All we care about are the coordinates. So we want to map the events to a set of coordinates, and the way that we're doing this is exactly like how we would do it for an array. So we can just call .map on the stream, give it a function, and it translates the value. So that is, map is an RxJS operator. RxJS has a lot of operators, and we'll look at just a couple of them. But you have all your basics, map, filter, et cetera, et cetera. But those are not the interesting ones. So now we can resubscribe to that click stream, the mapped click stream, and notice every time we click, we still get our old click events, but now we're also getting all the mapped click events with the coordinates. So just like with promises, you can create a whole chains of nested observables where you have one root one that is subscribed to by many others. And the great thing about this is that they're lazy by default. So this subscribe call here is what actually kicks things into gear. So you can create a whole bunch of observables, but if you never subscribe to them, nothing's going to happen. If you're new at this is a real gotcha. I'm not saying that it happened to me, but yeah, so you have to, it's a great thing performance-wise that you have to actually subscribe to them. So you can create them all eagerly and then just have them off to the side and then subscribe to them when you're ready to do something. So really, really convenient because it just allows you to model your data flow, and then you can kind of forget about the performance implications because it takes care of it for you. So as I said, there are a lot of observable operators. So now lots of these duplicate, like the map and the filter and reduce. Those are all just functions that would come in a functional programming library like Lambda. So we don't really want or need a lot of those, so what can we do instead? Which ones do we actually care about? Well, the observable operators that we really care about are the ones that deal with time. So the important thing about observables is how they model time and make that a first-class thing that we can reason about in our user experiences. So just by way of a quick example, imagine implementing the typical type ahead. Now, in order to implement a type ahead that works and doesn't suck, we have to keep a couple of properties in mind. First, we don't want to fire on every key press. We only want to fire when there's actually a distinct value in the text box that the user is entering stuff into. And then we want to debounce. We don't want to, send requests on every single change to that data. We only want to do it, however many times. So we've got to keep track of old values. We've got to have a debounce callback. And we also have to keep in mind strict ordering. So we're making network calls, presumably, for this type ahead. So every time that we call out to our server with an XHR request, one might come back. They're not guaranteed to come back in the order that we fire them off. So we have to maintain strict ordering. And how are we going to do that? And then for performance reasons, we don't want to keep old requests around. So if you have you always get that odd request that takes 5 seconds where the normal one takes 500 milliseconds. We don't want those old requests hanging around, choking up network that we could be using for other things or consuming server resources. So we have to do all those things, and the typical promise-based example not only would not be cancelable, but you'd have to keep track of all these things. So it's just a real mess. But in RX, it's actually really straightforward. So we implement this RX fetch function, which is just a convenience thing. There are libraries that wrap this and handle edge cases and stuff like that. But basically, like I mentioned before, you can convert any promise into an observable. So I just kind of did this for convenience because this kills the ability to cancel it. This is just kind of for demo purposes. So imagine that RX fetch is actually wrapping like a normal XHR call that's cancelable. Again, there are libraries to do that. I just didn't want to kind of go into that. But this is the entire implementation. So again, we have an input. We can intercept the change event and convert that to an observable sequence. And then we have an operator called distinct until changed that will keep watching on the upstream, and then once the value is different from the value that came before, then it'll emit to its downstream subscribers. And then debounce time, again, really simple. You give it a number of milliseconds and it handles debouncing for you. So users can type as much as they want, and the downstream will still only happen once every 400 milliseconds. Whenever the value changes, and once every 400 milliseconds. So when both of those things are true, then we get another downstream value in our sequence. And then we have an operator called flat map. So again, like I said, with observables, you have to keep track of nesting. So I have this RX fetch function, which is returning an observable that we're going to pretend is a normal XHR, not a fetch call. So I have to manually unwrap that. So I have to take this flat map function and, I'm sorry, I'm going to change one thing here. Flat map latest. You saw nothing. So flat map latest. What flat map latest does is not only does it unwrap that nested observable, but any previous observables that it received before, it automatically cancels them. So that takes care of our network and server overhead with previous requests. They're just gone. We don't have to worry about them. This also takes care of our ordering. So flat map latest is going to watch and make sure that we're never going to emit a value from an observable that's old. So as soon as we have a new observable, that one is canonical, the old ones are canceled, and our values maintain consistency, so you don't get that jitter from network traffic messing up your UI. So then finally you subscribe, and results, and then you update your UI. So does that make sense? Anybody have any questions on that? It's a little complicated, very condensed. Yes, sir.
I could use one more sentence on flat map latest. Exactly what it is.
Sure. So the purpose of flat map latest is to allow you to return an observable from an observable sequence. So whereas with promises, if you have an outer promise and an inner promise that you're returning, the promise abstraction will automatically flatten that. So the outer promise watches the inner one, gets the resolution, and then resolves itself with that interior promise resolution. But observables don't do that. You have to, because you might want that. And I actually have a code example I can show you guys to demonstrate that. So in order to do that, we have an observable sequence that's coming in of all the inputs, and then we're mapping out to another observable sequence of HTTP requests. So we want to fold that HTTP request into our one single stream so it's not nested. So flat map latest does that, and it also keeps track of whichever one's the most current, so it's not going to return any old ones, and it's going to cancel those old ones so that we don't have to worry about canceling them ourselves.
So if you just did RX fetch here without flat map latest, you get this weird nested complexity.
Yeah, exactly. So if I were to subscribe to just that, then the results wouldn't be the results. It would be the observable of the results that I would have to then subscribe to again inside my subscribe. Does that make sense?
Yeah.
Anybody have any other questions on this so far? Great, I'll take that as a no. So debugging and testing and debugging, this is where this stuff really shines. So we have a way to, well here, let me just frame this a little bit. So Michael Feathers is one of my favorite functional programming gurus. He has a blog, he's written all kinds of books. But one of the most important parts of functional programming is how, in software we have all kinds of moving parts, state is changing all the time, and it's hard to keep track of it with our tiny little human brains compared to a computer. Computers are very good at doing dynamic things, humans not so much. So ends up being the source of a lot of bugs, which is why stuff like Redux. Anybody use Redux or have used it? Okay, a few of you. Yeah, so the idea with Redux is you have your application and then you have the store, and the store is everything that changes in anywhere. So instead of having state encapsulated in objects that are nested in other objects and so on and so forth, everything goes in the store. Everything that touches your UI goes in the store. Your function, you have pieces of code in your UI that update the store, and then pieces of your code in your UI that subscribe to the store. All changes go through the store. That helps you reason about what your code is actually doing. So if you spot a weird thing, you're able to actually trace it back and say, oh, that came from here. So by itself, object-oriented programming makes that really hard because all of your pieces of a state are spread throughout all these different places. And again, small human brain can't keep track of all those places, which computers are great at that. So let's let the computer do that. Let's work with the computer. So the cool thing about testing is, imagine writing a unit test for the plus operator. Like, okay, I know JavaScript has a sort of a weird relationship with numbers, right? But let's just pretend that we're doing just regular old integers. Let's even say from like 0 to 100, right? So super simple. Yes, I know sometimes like 7 equals 8. We're not talking about edge cases here. It's just regular old addition operator. Think about writing a unit test for that. All you need to do is take the operator and 2 values and create your expectation for what the output's going to be. You don't have to mock anything. You don't have to have any fixture data. You don't have any test setup. You just test it. And think about, and obviously that's sort of an absurd example, but think about that compared to object-oriented programming, where you have, mock objects and different things like that you have to do all this setup in order to create the conditions for this thing to exist. But if we go back to this example here of this guy. So imagine testing the names function. You don't have to set anything up. You just have your names function and you call it, and then you assert what the output's going to be. Like, there are no moving parts here. All of the moving parts are tied down. They're encapsulated. Or I'm sorry, they're just eliminated because we don't have them. We're not we're not socking state into any objects. The state's just not there. Now, ultimately, at some point, you always have to have state because otherwise things can't change. But the point is that you isolate it away from your logic. So testing with this stuff becomes extremely simple. So what you end up being able to do is you have observables with all these operators that allow you to manage time. You don't have to test those. Like, you can test them as part of your whatever it is, end-to-end testing strategy that simulates users in a browser and stuff like that. But as far as unit tests, like, you don't have to test those operators. Like, the RX team has already done that for you. And once you separate those observables and just using those time-based operators from all of your functional code here, like, that makes your whole testing strategy very, very simple because you just have all these functions that you compose together. Let's take a look at a slightly longer example. I'm gonna do this. All right, so Ramda has this fun function. They put the fun in functional, called pipe, that allows you to do things like this. Let's say you have tasks equals, I'm gonna live code. This is so dangerous. Oh, that is the wrong screen. Oh shoot, how do I even do this? Oh, all right, now I can't see. That's okay. I didn't really need my neck that badly anyway. Task 1, yeah. All right, can everybody see that? Awesome, I got a yes. So I have this data, and you can use your imagination and pretend it's coming from the server. Oh, and complete equals true. And then, oh, yeah, it's getting really hard. Hang on.
Mirror your express.
Yeah, I'm totally gonna do that. Boom, solved. All right. So very cool. Oh, and now my screen is gone. Come on. All right, and we're back. So I have some tasks. We'll just make one more. All right, task 3, complete equals false, owner equals Nate. All right, so we got our tasks, cool. So now what we want to do is I only care about me, and I only care about the stuff that I don't have done yet. So I'm going to write a function, my incomplete tasks. And Ramda has this pipe function that allows you to define a function with other functions. That's that whole like high order thing, right? So what I'm going to do is, first I want to filter out the things that are not complete. So where AQ is a function that takes one function and compares it to another function and returns true if the comparison checks out. And I'm going to pass that to filter. So So here, let me just break this down a little bit. So here, I have a filter function. And my incomplete tasks, please work, please work, please work. Yes, all right. So now I have it filtered down to incomplete tasks. So now I want to redefine that as a multi-step operation. And I'll just create a little space here so we can kind of see what's going on. And then I also want to filter where the owner property is Nate. Again, I'm sort of doing the same thing, and like you can put this in so many different ways. Like you can say, you know, request reject where eq complete equals true. Like there's all kinds of different ways to say the same thing. Whatever's the most succinct for your use case is the best. So now I can add another step, this other filter, and then I'm down to 1. So now I want to say tasks, that was the third task, so I'm going to do task2 dot do equals date dot now. So it's past due. I'm in trouble. Yeah. So I'm going to do that, and then I'm going to push another one. Task 4, complete false, owner Nate, do now. By the way, now is stateful. So if you're calling that in your peer functions, bad news. You got to pass it in. Pass that in. Hot tip. All right, so now we got 4 tasks, and so we want to sort our tasks by how bad I have to panic. So sort by do. And we'll just add that to the pipe and then recall it. Oh, let's try that again. Wait, let me make sure sort by is still a function. Sort by, right? Yeah. So these are all of the functions that Ramda gives you. There are a lot. Oh, I think I know. Hang on. I got to do sort by prop do. Let's try that. Yes. Right? Come on, give it up. Live coding. So functional programming in this style, like actual functional versus non-functional, like Lodash, allows you to compose very, very complex behaviors one step at a time, and allows you to reason about those behaviors in an extremely simple, concrete way. So combined with something like observables to handle all of the other stuff, all of the mechanics, all of the getting data from different places and sequencing events and all of that stuff. Once you've got the data, you can subscribe to those observables, get the data, and then just pass in these very simple functions. So my incomplete tasks, I can just take that and pass it by itself to a subscribe on an observable that gets, let's say, task data from a server. So again, I don't have to test that observable. That's already tested for me. I can test it if I want as part of my like end-to-end functional testing strategy. But all I have to test for my business logic is this guy here. And that's so simple. There's no complex setup. I literally just did what I did here. Set up some data, pass it in, make sure that the thing that comes out is what I expected. And then what's great about this is you can extract these middle parts out and then compose them together into other things. And the whole thing just works in a very, very simple way because you have these little pieces of functionality that you can test in isolation, then compose up into higher order things to sort of structure the overall logic of your application. So I think it's pretty cool. Any questions? JB?
Why aren't observables part of like JavaScript, like ES6? Make sure you repeat the question.
Yeah. Great question. So why aren't observables part of ES6? So there's the generator proposal for ES7, which is for something called generators. That achieves similar things, but the magic of RX is all of its operators that encapsulate the different time coordination for you. So, I mean, it's kind of a hard thing to bake into a language. I don't know, it's a good question. Because it's like, it makes sense as an abstraction. I don't know, I mean, JavaScript has never had a great standard library, so I guess that's the answer. JavaScript has never had a great standard library. Yes?
To a certain extent, isn't an observable just like a class of many other things, like a promise or something like that, or like an iterable, or isn't it more of a grouping than a thing itself?
Yeah, so that's a great question. So the question was, isn't observables really just like a grouping of things rather than a thing itself? And that's basically true, but then so is an array, so is a promise, so is all these other things. The thing about observables that's great is it allows us to reason about all those different types of things, events, XHR, any kind of asynchronous thing. It allows us to reason about all of those things in one way. It's an interface essentially. It's a well-defined interface that allows us to take that massive library of operators and operate on all these different kinds of things in the same way, regardless of where they are or what they are or where they came from. Does that answer your question?
Yeah.
Great. Yes?
Stepping back to your RX fetch example earlier.
Yeah.
I had a question about that does relate to observables. HTTP requests can take varying amounts of time. Maybe one of the early requests actually replies later. Does the code you show there address that, or is there an easy way to address that, like making sure it winds up that you get the latest result as the last result you actually receive?
Yeah, so great question. So the question was, how do you deal with the sort of inherent network issues where you have no guaranteed ordering in terms of when you fire off the requests versus when you receive them back? Is that a fair summation? Okay. So again, RX has all kinds of different operators to deal with time in different ways, of which flat map is one. So flat map allows you to have an observable that is mapped to another observable, so you nest them, and then that allows you to keep track of whichever one's the latest. Like I showed on that slide back a little while ago, there are a whole bunch of operators. It's here somewhere. Just stay with me. There's a better way to do this. All right, here we go. So yeah, like I said, whole bunch of operators. So each one of these different operators deals with different semantics for how to handle time in different ways, how to handle time and coordinate different things across time. So it just depends on what kind of semantics you want for your interface. I pretty much guarantee there's an operator that will handle that case, or the composition of a small number of different operators. Does that answer your question?
Yeah.
Great. Next. Yes?
When I started looking into RxJS, I understood observables, but subjects sort of drew me through a loop. Could you sort of touch on how they fit into the puzzle?
Sure. So the question was, diving into Rx, I understood observables but not subjects. And I'm probably going to get this at least partially wrong, but basically subjects, so in order to have an observable, you have to have something that you can subscribe to, which is an observer. So there's lots of different ways to create observers. Most of them are internal, like observable from promise returns you an observable, where the observer, the thing being observed, is the promise. Again, I'm almost sure I'm getting something wrong in this answer, but the gist is that a subject is both an observer and an observable. So you can chain things off of it, you can listen to it, but it also has observer methods that allow you to push values back into it that will be rebroadcast. So there's one called replay subject, which by default, like let's say our click example, right? I set up the observer, I'm logging. If something else comes along that needs to subscribe to that click observer, it's not going to get any past events But there's a class called a replay subject, which allows you to set up a buffer of n number of items that can be replayed to any future subscribers. So that's one of the use cases for that. Generally, you don't need to create subjects. Like, there are already encapsulated classes for you that will handle most of the needed behavior for that sort of thing. Does that answer your question? Awesome. Yep.
So we use this for like back-end data processing, like this approach. And a lot of times we'll see in our code base that like 60 or more percent of the code is, like in our case, it's Highland, right? So like the majority of the code is Highland implementation because the logic is like fairly straightforward. So curious what your opinion would be on the value of buying into like using that tool everywhere versus like writing your own code, which is all under your control. Like by writing your own code, I mean like extracting those functions or like creating those functions yourself. So they're all.
Yeah, okay. That's a good question. So let me see if I can rephrase this accurately enough. So you use observables already to handle a lot of data processing, and you're wondering, so you don't have to write a lot of code because the code's already in the library. So what's the value of opting into that versus writing your own stuff? This stuff like this is great because dealing with time in programming is hard. Like, we don't have a lot of good abstractions for it. So library authors have already seen most of the edge cases. So, I mean, there's value in that. There's value in, you have all these operators that you don't have to reinvent. I mean, there's always use cases for it. Like, if something is, you have just a slightly different use case that you just can't squeeze out of the existing implementation. Usually, like, RX will let you make your own observers, just raw. So like, and you can implement your own operators. I guess, does it really have to do more with like vendor lock-in maybe? Or like being locked into a certain API?
I think that's more my point.
Okay, yeah, that's a great question. So that was kind of part of my point here, where it's like, okay, there are all these operators. You really only need to care about the half dozen or so that deal with the time semantics that you care about in your application. So you don't have to buy into all of this. And that's why I like using this with something like Ramda, where Ramda is like a you have very, very simple, pure functional programming library, right? And so opting into that is like almost like opting into the JavaScript standard library. Like, I would never not use this, and the operators are so low level that I would almost never reinvent them. Does that kind of make sense? So it's like, pull from this what's really important, ignore the rest. Any other questions? We're probably about at time, huh? Okay. Final question? Yes, no? See me after class? Yes, okay. Hi.
Hey, I just wondered, you mentioned like Cycle.js and Angular 2 as like observable pattern friendly.
Yeah.
As far as generally like different front end stuff that's out there, that's some that are more friendly to this approach.
So the question was, I mentioned Angular 2 and Cycle.js, which are both frameworks that have observables baked into the core and give you nice abstractions for working with them. They're like observable frameworks, basically. What was the second part?
In terms of other front end frameworks that are more friendly, if you will.
Sure. Other front end frameworks. I mean, React is pretty good. Like, React doesn't have anything, it doesn't offer any abstractions natively to work with observables, but React's design, like especially when you have pure function components and stores and things like that, it lends itself to working with observables easily. So anything that has those similar kinds of properties you're not gonna have a problem. Does that answer your question? Great, okay. All right, then I guess that's our show, folks.